Hello everyone, welcome to MindMatrix. So here we are with the first lecture on operating system, and today we are going to start. So before starting, let me introduce myself. My name is Anshul Sharma. I'm upcoming software engineer at Juniper Networks. I'm currently pursuing M.Tech Computer Science from IIT Kanpur. I also have teaching experience of more than 2 years. I have mentored more than 1,000 students, and I have expertise in computer science and data science subjects. And I have secured All India Rank 294 in GATE Computer Science, cleared ISRO and NIC NELET exams. Also got selected as administrative officer at AIC. So guys, let's start our today's lecture. And here we are. Yeah, before that, do join our doubt discussion Telegram group. So here you can scan this QR code and you will be able to join our Telegram group. Okay. So first of all, before starting, we need to see here that what are the reference books that you can refer, the standard textbooks. So here we have this one, the Galvin. Most of the students and even in the colleges, they refer this book, Operating System Concepts by Galvin. And if you study this, if you give a read to this book, definitely you will be able to understand, you will be able to get a lot of things from this book. And that is also very important to get much more clarity in the concepts if you are studying by yourself. Yes, and we have other books also like Operating System Internals and Design Principles by William Stallings, and this one, Modern Operating Systems by Tenenbaum. So you can refer any one of this book if you want to. But if you are watching our lectures, definitely you don't have to spend most of your time in reading books. You can just watch the lectures, make some notes, and you will be able to solve the questions as well. If you talk about the GATE syllabus for operating system subject, so we have this system calls, processes, threads, inter-process communication, concurrency, and synchronization. There is one topic that is a deadlock. Then we have this CPU scheduling and input-output scheduling. Algorithms we talk about here. Then we have, this is very important, memory management and virtual memory. And at the end, we have file system. So we will be covering most of the units of this operating system in our YouTube lectures, okay? So let's start with the definition first. What is operating system? So I hope most of you are aware of it, but still let me, as we are covering from the scratch, from the fundamentals, so it is my responsibility to cover each and everything, right? So what is operating system? So we know this, that we have one user, right? And we have the hardware. So if a user wants to access some hardware, let's say printer, so in that case, there is a requirement that there should be some interface, right? There should be some interface which can connect this user with this hardware so that we can access that resource properly. So basically, operating system, this is one of the functionality that I'm talking about. But overall, if you say operating system, it is a program. It is a program that controls the execution of application programs and acts as an interface between the user of a computer and the computer hardware. So this is very important that we are calling operating system as a program, right? So we later on in the lectures, I will be telling you most of the things related to this one. Okay, let's proceed further. OS controls the allocation and use of the computing system resources among the various user and tasks. So there are various resources that is connected to the computer, right? And we want to access that. So OS provides that functionality to us, right? OS handles that allocation and deallocation of the resources properly. It provides an interface between the computer hardware and the programmer that simplifies and makes feasible for coding, creation, debugging of application programs. So if you summarize all these 3 points, you can clearly say that OS acts as an interface between the user of the system and the computer hardware. In short, you can clearly say this. So now we know what is operating system, right? Now we will talk about why do we need operating system, right? What is the requirement actually? We need to understand it, right? What is the intuition behind it? So that we need to understand to proceed further in this subject. So now let's see here. Let's say there is one user and let's call this user as Bob. So Bob is one user and he writes some code. So int main and certain statements are there. So this user writes one code and in the C programming language. We have considered C programming language. So demo.c is the name of the C file. Okay. Now this file is given to the compiler. Okay. So here we are not going to discuss the steps of the compiler because that we are going to cover in the compiler design subject, right? Separately. You just need to understand here that this demo.c file will be compiled by the compiler and further by assembler, and it is going to give you the executable code. Let's say this is a.out. Okay. So this is the executable file that you have, which is basically binary file, right? You have zeros and ones. So this is the a.out file, that executable file, which is having the data and the instructions that we need to execute. Okay. So this executable file, this entire file will be loaded into the main memory. So we have the main memory in the system, computer system, we have the main memory, right? That is the RAM. So we are going to load this entire executable file into the main memory. So in order to execute any program, you need to load first to the into the main memory, and then you can execute that. Okay, this is the process that you have to understand. So we load it. Basically, we use loaders for loading the executable file into the main memory, and then we execute it. So we have this is the memory layout we have. So here we have the operating system in the main memory, right? We have the stack, we have heap, data, and instructions. So for dynamic memory allocation, we use heap, right? For activation functions, or if we call any function, so for that purpose we need stack. Here we have data and instructions. So we have loaded the program, that is the we can say the executable file we have loaded into the main memory. Now we need to execute it. So in order to execute it, we need to first know what is the starting instruction, what is the first instruction that need to be executed in order to execute this program. There is one more concept here that we need to understand here. This is the program counter. So what is program counter basically? Program counter stores the address of the next instruction to execute. Okay, program counter stores the address of the next instruction to be executed. So here we have the processor, that is your CPU. Here we have the main memory. Now here you will be in the program counter, you will be having certain address of the first instruction to be executed. So the first instruction to be executed, the address of that will be stored here in the program counter, or basically we say the next instruction. So when we start, so that is going to be the next instruction, right, to be executed. So here this is the overall idea of how we load the program into the main memory and then we execute it. It is very important to understand this one. Okay, then only we can relate why we need operating system in the first place. Okay, so let's proceed here. Now let's say this is the program that the user Bob has written. So you can see here we have certain header files, hash include stdio.h main function, and here we are printing printf MindMatrix. So we are printing it, and then we are returning 0 because it is int function, main function. Now your CPU, what it does, your CPU is going to fetch the instruction one by one. So fetch will be there. It is going to decode it. It is going to decode the instruction, and then it is going to execute it. So finally what you get on the monitor, that it is printed MindMatrix, right? So in this way your CPU will be executing the entire code that the user has written. So now you can see clearly that on the monitor you are having MindMatrix. Now there is this is very important to understand here, that your printf, here you have written the printf statement, right? Now what this printf is doing, it is printing on the monitor. Internally there will be some working, I will let you know later on what are the system calls that are associated with printf. But just to get a basic idea, when we are writing printf in our code, that means we want to display it on the monitor. Simple. Yes. Now this cpu, this cpu does not own, the cpu does not own the monitor, because this is the input output device, right? This is the input output device, this is separated, this is different from the cpu, the processor, right? So this to access this input output device, you need someone, you need someone. So this monitor is external input output device, and cpu has to take permission, right? If a cpu wants to access this monitor, it has to take the permission, right, from the monitor, that I want to access you, please grant the access, right? So it's fine. Let's say manually, manually we are allowing it. Okay, so first of all we will be setting the initial let's say we will be initializing the program counter first. Okay, the instruction to be executed, fine. And then it is going to fetch it, it is going to fetch the instruction, it is going to decode the instruction, then it is going to execute the instruction. But during the execution phase, it is going to request the monitor, right? The cpu is going to request the monitor. So finally let's say if it is happening manually, then we are going to grant the access to access the monitor, basically to the cpu. We will grant the permission that okay cpu, you want to access the monitor, you can access it simply. And then we are going to increment the program counter by 1, that means the next instruction to be executed, and so on, right? Now let's assume we have two programs running simultaneously. Okay, so now we are not considering that there is any operating system, we are just considering that without operating system how we are going to execute the programs. So now let's say you have this main memory, and now you have two programs, program 1 and program 2. Now let's understand it carefully. Now you need to know where your program 1 stores in the main memory, right? Similarly, you need to know where your program 2 is residing in the main memory, correct? Right, when we consider two programs. So you need what? You need to have a bookkeeping. That means you need to store somewhere. So memory management is required. Memory management is required because you have to store somewhere where your program 1 resides in the main memory. Similarly for program 2, if you have two programs, right? So memory management is required, correct? Let's say another case, when your program 1 wants to access printer, and let's say it is accessing the printer. Similarly, your program 2 also wants to access printer. So in order to grant the access of the printer to the program 2, you need to first check whether the printer is already in use or not, right? If the printer is in use by the program 1, then you cannot grant the permission to the program 2 to access the printer, correct? So what do you need here? You need what? File you need this resource management as well, because printer is a resource, so resource management is also required. Are you getting this? Resource management is also required, right? Now you can see here that if we have just two programs, we need to have memory management, we need to have resource management. And let's say we are now consider a case when we are executing multiple programs. when we have multiple programs in the main memory and one by one we are executing it. Let's say it is a uniprocessor system. That means we have just one processor. So at a time we are executing only one process. So we need to have this memory management, we need to have resource management. Similarly, file management will be also be required, and lots of other things are required. Security is also required, right? So you can see, if operating system is not there, it is going to become really hectic, and almost you can say impossible, because you need to manage so many things together that it will become almost impossible for a user. So that's where we can understand that we need operating system in place. We need operating system in place which is going to handle your memory management, which is going to handle your resource management, your file management, and everything. So that is the need of operating system. So we have started just from the basic. We understand what is operating system, we have seen it. Now we have understood why we need operating system, right? Because if we are studying about certain topic, we need to first know what is the need of that, right? If we don't know the need and we are just studying it, that means we are not getting the fundamentals clear. So this is very important. So here we can understand why we need the operating system. Now let's see here, running a small program on CPU. So here if you see, we are having certain we are having one variable a, and the value stored is 10. We are having one variable b, the value stored is 20, and what we are doing is we are adding these two variables values, and we are storing that in C, right? So here again we can understand here that this is your program. You will compile it, right, and you will be getting a.out file. Let's say you have some cal.c, the name of the file, and after compiling you are getting this executable file which you are going to load to the main memory, right? So you can understand that you are going to set the program counter value to the first instruction of this, where you have a.out, you will be loading into the main memory. So you will be having the program counter value, which is the next instruction to execute, correct? Then again the CPU cycle will be there, which is having all the phases: fetch, decode, and execute, right? And then you are going to increment the program counter. So without operating system, it is very hectic. It is almost impossible to do all these things, right? If you have, we are just considering one program manually. Let's say for one program you can do, for one program we can do without operating system, but when we have multiple programs, then it is almost impossible for us to execute the programs seamlessly. So that is the case where we need operating system. We understand the need of the operating system, clear? So so here you can see all the steps we have. To run this, we need to know, write this program into some memory. First of all, the executable file we will be loading to the main memory with some address a. Then the CPU, tell the CPU that your program is located at some address a. Your CPU need to know, right, where the program resides in the main memory. So this can be done by setting program counter to the address a. Then CPU runs the program using fetch, decode, execute cycle, and program ends and you get the results. So for smaller programs, it is not difficult as such. But we have more programs, as I made it clear to you. Then in that case, it will be really difficult for us to do it manually. So we need operating system. So according to Galvin, we have taken this excerpt from Galvin. You can see here, we can also view a computer system as consisting of hardware, software, and data. The operating system provides the means for proper use of these resources in the operation of the computer system, right? So proper utilization of resources will be provided by the operating system. An operating system is similar to a government. Like a government, it performs no useful function by itself. It simply provides an environment within which other programs can do useful work. Clear? I hope it is clear to all of you. And now let's understand what are the functionalities of operating system, what are the services provided by the operating system. So it provides the user interface, right? So that varies between, command line argument, graphical user interface, and batch. So for, like, we can say for Windows, it provides different user interface. For Linux, it is command line interface. So it is different for all the operating systems. So it has the functionality of providing the interface, beautiful interfaces also. Program execution is one of the services provided by the operating system, loading the program and running it, right? Then we have input output operations, that is also being handled by operating system. File system manipulation, let's say you want to store files, multiple files, right, in the memory, then your operating system will provide that management also, file system management also, and manipulation also, if you want to done any a certain task. So communications, yes, shared memory or packets. So basically shared memory concept we will be talking about later on when we talk about the inter-process communication, right? But that is also being handled by operating system. Error detection, taking actions, and debugging. So that is also being provided by the operating system. Resource allocation, so functions for efficient operation. Resource allocation, if a program needs a printer or some other resource, some shared memory, then all that will be taken care by operating system. Accounting, keep track of which users, how much, and what kinds of computer resources are required. Protection and security is also being provided by the operating system. So you can see lots of functionalities are being provided by the operating system, which is very important, and that's why we need operating system in the first place, right? Now let's talk about the types of operating system. So the first type we have is batch operating system. Now what it does, so operator takes similar jobs having same requirement and group them into batches. So here you have the operating system. Let's say you have job 1, job 2, job 3, and so on, right? Now this batch operating system, we have one operator which is going to take the similar jobs. So let's say job 1 and job 2 are similar. So in that case, it is going to group them into a single batch. Similarly, we have let's say job 3 and job 4, or maybe job 5. Then in that case, it is going to, if they are similar, it is going to group them into a single batch. Okay, so then one by one, the batch is going to be executed by the CPU. So this is, we have the batch operating system, and that is not used now. It was used early in 90s, even before that, right? What are the advantages and disadvantages of batch operating system? So multiple users can share the batch systems. That was the advantage. Idle time for batch system is very less. So one by one batch is going to execute. It is easy to manage large work repeatedly in batch systems. So if you have a really large programs to execute, so in batch systems you can easily do that. What are the disadvantages? Priority cannot be set for jobs. So this was one of the disadvantage, that if you want to set a priority for a certain job, you cannot do it, because as you know, multiple jobs, multiple similar jobs are going to be grouped into batches. So you cannot define the priority for that. And it may lead to starvation because of a batch taking long time for execution. This is one of the advantage. Let's say if you have one batch and it is taking very long time for the execution, the subsequent batches, right, they may face starvation. What is starvation? Indefinite waiting. So they will keep on waiting for the CPU access. Hard to debug. Yes, if you are grouping multiple jobs into single batch, then it will be very difficult to debug it. This is very important. Second type of operating system is time sharing operating system. So in time sharing operating system, each task is given some time quantum to execute. Now, before understanding time sharing operating system, let me tell you two concepts. One is multi-programming, and other one is your multitasking. Now, what do we mean by multi-programming? So as the name suggests, multi-programming means when we have multiple programs in the main memory. When we say programs, basically when we have programs in the main memory, programs under execution, programs in execution becomes process. So let's say when we have multiple programs in the main memory, then that concept is known as multi-programming. So one by one, every program is going to execute, right? And there is no preemption in case of multi-programming. There is no preemption. That means first one program is going to execute, then the next program is going to execute, and in this way it is going to proceed further. But when we talk about multitasking, so in case of multitasking, multiple tasks are being executed, and preemption will be there. That means for certain time quantum, you are going to execute one task and then you are going to preempt it. You will be assigning the CPU to another task, and then for that certain time quantum, second task will be executing. So this is multitasking. So sometimes they may ask difference in GATE exam. They are not going to ask the difference, but you should know what is multi-programming and multitasking. In interviews, they may ask you the difference. So here, this time sharing operating system, basically it is the extension of this multitasking, or you can say it is based on multitasking. Clear? So in multi-programming, preemption is not there. One by one it is going to execute, but in multitasking, preemption is there. That means you can preempt a process and then you can execute the next process or next task. So each task is given some time quantum to execute. Let's say you are doing certain work in Word document. You're also accessing the email. You are also accessing the browser, right? So these are the various tasks you have, right? So it may seem to a user that all the tasks are running simultaneously or concurrently, right? Simultaneously we can say, but it is not like that. For certain time quantum, your Word document, it is going to get the CPU access, it is going to execute, then for a certain, it is going to preempt it, then for a certain time, email will be accessed or will be executed, email processes will be executed by the CPU. Similarly, browser also. So this is time sharing operating system. Clear? What are the advantages and disadvantages of time sharing operating system? Each task gets equal opportunity. So this is the advantage, because we have set some time quantum, right? Let's say it is a 2 millisecond, for example, 2 milliseconds. So for 2 milliseconds, every task is going to execute. Clear? So each task gets equal opportunity. Less chances of duplication of software, which is quite obvious. CPU idle time can be reduced. Yes, CPU idle time can be reduced. Why? Because for a certain time, every task is going to execute. So there is a very less chance that a CPU will sit idle, right? What are the disadvantages? Reliability problem, a data communication problem, because after every time quantum, you are going to switch to another task. So some data communication problem and reliability problem may exist. And these are the examples. Now, distributed. Third one is your distributed operating system, which is also called as loosely coupled system. So in distributed operating system, you have a single operating system here, which is going to access multiple resources. So in this one, you have its own CPU, its own secondary memory, its own main memory. Similarly here also. So separate resources are there, but that is being handled by a single operating system. So this is distributed one. What are the advantages of distributed operating system? Failure of one will not affect the other network communication. It is quite obvious here. If let's say this set of resources faces some failure, in that case it will not impact these resources to access the operating system. Clear? Computation highly fast as resources are shared. So computation will be too fast because resources are shared, multiple resources are also there. Less load on host computer, correct? Delay on data processing reduces. So data processing will also reduce delay because you have multiple resources shared by the single operating system. Disadvantages: failure of main network will stop the entire communication. Let's say if this main network goes down in some cases, then the entire system will stop the entire communication. I mean, it will not work properly. It is very expensive because a single operating system is handling multiple distributed resources. Clear? So this is we also call it as loosely coupled system. Now, fourth one is your network operating system. So it is a tightly coupled system. So here you have one single file server. So this is the example of a network operating system where you have a single file server and multiple clients. When we say clients, it can be browser, right? Multiple browsers are trying to access this single file server, right? Or multiple users are trying to access this multiple single file server. So this is network based operating system. So shared access is over a small network. So this is tightly coupled system. Advantage is highly stable centralized server because you have a single file server. So that is going to be centralized and highly stable. Security concern handled through servers. If there is any attack or something, so it can be handled through the servers. Server accesses are possible remotely. So remotely you can access, as you can see in this case also, all the clients are remotely accessing the single file server. What are the disadvantages? Costly servers, maintenance and updates required regularly because all the clients are accessing that. So you need to have the regular updates and maintenance. And these are the examples of network operating system. The last one we have is a real-time operating system. So as the name suggests, real time, so it is related to the time interval and response time are very small. Further, in real-time operating system, we have two types. One is hard real-time operating system, other one is soft real-time operating system. When we talk about hard real-time operating system, the time constraints are very strict. For example, let's say some air traffic controller system is there. There you cannot afford a slight delay also, right? Even a slight delay can cause the loss of life or a big damage. So in that case, the time constraints are very strict. There you need hard real-time operating system. Let's say you have to launch a missile, you cannot have a delay in that. You have to launch a satellite, you cannot have a delay in that, right? So these are hard real-time operating system. The deadlines are fixed, the time constraints are very strict, and there is no concept of virtual memory. Virtual memory never found in case of hard real-time operating system. Okay, but when we talk about soft real-time operating system, time constraints less strict. For example, let's say you are using MS Paint, or let's say you are gaming, right? So in that case, if there is even a slight delay, it is not going to cause a loss of life or any big damage, right? So in that case, you can have a soft real-time operating system where time constraints are less strict. Yes, there is some time constraint, but it is not very strict or it is not hard. Clear? What are the advantages and disadvantages? So in case of real-time operating system, maximum consumption, took shifting, focus on application. RTOS, real-time operating system, can be used in embedded systems. So in most of the embedded systems it is used. It is error-free, memory allocation best managed. Memory allocation is managed in a best way. What are the disadvantages? Limited tasks, heavy system resources usage, complex algorithm, need specific device drivers and interrupt signals based on the requirement basically. So weapon systems, air traffic control system, these are the examples of hard real-time operating system. I have given you already the examples of soft real-time operating system. Clear? So that was it from the first lecture. I hope you really enjoyed it, and if you have any doubt, you can join our Telegram group, and this is our MindMatrix channel on WhatsApp for all the updates and for all the videos that we are posting on our YouTube channel. You can get all the updates there. So you can join both this channel on WhatsApp, and this is the doubt discussion group. For doubt discussion group, you can also scan this one, this QR code, and you will be able to join our doubt discussion Telegram group. Also, we will be posting the PDFs of all our lectures that we are going to take on YouTube. We will be posting all those PDFs in our Telegram group. So do join it, and if you have any doubt, do ask in the group. Both myself and Sachin sir will be answering your doubts. Okay. So stay tuned for the next lecture. I hope you really enjoyed it, and we will see you in the upcoming one. Okay. So thank you everyone. Bye bye.